Welcome everyone. We will be covering SQL storage fundamentals for Azure VMs. Those of you who don't know me, my name is Bob Duffy. I've been around this sort of database sector a long time, 30 years now. I'm not going to show my age, right? I'm a SQL Ranger, an MVP, an MCM, and Azure Services Maestro. I guess the most important thing is I spend a lot of my time helping customers optimize their infrastructure, be that on infrastructure as services or platform as services. And this talk really comes from our experiences of configuring SQL to run optimally, and also we're cheapskates. So what that means is we want to get the most out of what our customers pay for and see if we can find out what the rules are and how to abuse them, right? So that's really what this talk, well, not abuse them, optimize them, right? So this is what we're going to chat about, right? There's a 5-step plan I have to give perfect configuration of your storage, right? In terms of format for this talk, feel free to stick your hand out or shout out a question. I'm quite happy to stop and chat sort of briefly about any points. It's a 50-minute session. If there's something that's relevant to a slide, but what about this? But what about that? These are all good questions, right? So we'll start off with one of the fundamental concepts. I'm assuming that most people in this room are running SQL on infrastructure as a service. Just have a show of hands if you're currently running SQL on infrastructure as a service. Yeah, so a few, right? And then, so obviously you'll probably be already familiar with the first concept, which is your disk isn't actually a physical disk, it's effectively sits on a blob store, which is geo-replicate, well not geo-replicate, it's replicated within the sort of data center 3 times. And if you had geo-replication on your blob storage, which you generally don't have on a VM disk, it could be replicated up to 6 times, right? So the key point in this is that you don't worry about traditional on-premise things like, you know, RAID 5, RAID 6, RAID 10, and stuff like that. That concept, I don't see anybody really applying that to configuring SQL in Azure's. High availability is already taken care of, and because of the replication, you are going to, if you're moving from on-premises, you're going to get a bit of a write penalty because it's a synchronous replication within the sort of data center. So obviously writes are going to be slower than they would be on your single SQL server that you might run on premise. So to start off with, the first thing that we try and do is capture requirements, right? Which can be very hard if it's a greenfields project where you haven't actually built anything yet, right? But if you have built something, you're going to want to understand what workload are you trying to run, right? And this generally means knowing your IOPS, your throughput, and roughly how your workload works in terms of the 3 important components. There's 3 critical components for any SQL server. It's data, log, and tempdb. They all have different I/O requirements, and just knowing a little bit about them helps, right? If you have an existing workload, there's lots and lots of ways of capturing this. So on screen is a list of 7 common capacity planning metrics that you can capture in perfmon. You can capture the IOPS by looking at disk reads per sec, the throughput in terms of how many megabytes per second you can capture by read bytes per second. And there's various other metrics that will give you the throughput on the tempdb, the percentage of workload in tempdb, the read-write ratio, and so forth. You can also get this, a really cool way is by going in to the DMVs inside SQL Server. So there's a great link. I will put these slides up so you'll be able to get hold of the links. So there's a link where someone has some T-SQL queries where you can go into the virtual I/O stats and pull out a lot of this capacity planning information if you have an on-premise that you're moving to an Azure VM or an existing Azure VM workload, right? The key thing to understand is I try and never talk about IOPS, right? I always think of throughput, right? And the reason is IOPS is a misleading term that sales and vendors use to say how great their equipment is, but it doesn't really tell you much. So just to sort of prove a point, right? Who thinks that 500 IOPS is a lot? Okay, hand it up. Right. Who thinks it's not a lot? 500 IOPS. Yeah, it doesn't sound like. What sort of storage do you think could do 500 IOPS? Anyone think a USB key can do 500 IOPS? Yeah. Yeah, I'd hope so, right? Well, the key thing is, maybe not. It depends on the I/O size, right? If your I/O size is 8K, then 500 IOPS is only 4 megabytes per second, which a USB key can definitely do that. If your I/O size is 4 megabytes, and SQL Server world, you only get that on a backup, right? It's going to be 2 gigabytes per second. So suddenly, the class of storage is completely different, right? A USB key is definitely going to do 4 megabytes per second, probably not going to do 2 gigabytes per second. So this is why I like to talk about throughput, because if you only talk about IOPS and not I/O size, you'll get confused, right? SQL Server is quite an easy thing when it comes to I/O size. So this is a very old, which hasn't really changed over the years, of what the I/O patterns of kind of SQL Server are, right? And what you'll see from there is nearly everything works in about 64K chunks. So we generally assume the I/O size of any SQL Server is 64K, right? So if you don't know the I/O size, assume it's 64K, right? The exception to that is if you're running Enterprise Edition for high table scans, so we're talking here data warehouse workloads that are very large with very large table scans, the engine will do I/O sizes up to 512K in parallel, right? So this means your I/O size can be greater than 64K. And this is where fragmentation basically means it's not efficient as it could be, right? So if you've got a really well-tuned, you can see I/O sizes very common, 128, 256. Getting a 512K I/O size, you would need to have the world's greatest DBA, right? It's quite hard. But certainly 128 and 256 are very common for data warehouse. So what I like to do is when I capture the I/O, I'll make a chart and put all the I/O into sort of buckets, and I'll say, well, for how many times has it done this I/O, that I/O, that I/O? And what I'm doing is I'm building the I/O pattern of the kind of SQL Server, and when I specify the requirements, a common thing in capacity planning is we talk about the 99% quartile. And for some weird math, I've spent about 15 years doing capacity planning, and I use stats to calculate the 99% quartile, and it's nearly always double the average. So the old thing of find the average and actually double it isn't actually a bad, works out quite well. So this is how we say, for example, on this chart, the 50% quartile tells us about 9,000 IOPS, right? But we don't want to build a system that only does 9,000 IOPS, because then 50% of the time, it's not going to meet its requirements, right? So we'd build a system that does maybe 18,000 IOPS, right? So whatever the 99% quartile is, right? Hopefully, by the time you've got the capacity planning, you'll have some sort of data like this, right? And say, well, I want to build my data log and TempDB. This is the throughput I need. Latency as well is important because different types of disk have different types of latency, right? And it's a holy grail. If you can get this as a set of requirements, you're doing very well, right? Once you've got that, you can look to pick your VM in Azure, right? Now, the key thing to understand from this chart is that VMs come with two separate pools, your cached pool and your uncached pool, right? And a disk can be either cached or uncached. And there's different limits of throttling applied to both of those, right? So on a favorite old VM of mine, the DS14, you could get 768 uncached throughput, megabytes per second, and 576 cached megabytes per second. So if you only use one of the components, So if you throw all of your disks on cached, you're only going to get a fraction of the throttling capability of the VM, right? So once you know you have 2 pots, if you can abuse them both, you can optimize to get more total throughput, right? Now, the local disk is a special case. That comes out of the same provisioning limit as the cached. So if you can only do 500 cached, if you put it, say for example, your kind of server's blowing up because of your sort of temp DB, and it's on cache disks, and you move it to the local SSD, it's probably going to make no difference, because once it hits that kind of throttle, it's not going to do any more, right? But if you haven't hit that kind of throttle, the kind of local SSD can be beneficial to put the temp DB on, and also because it's not a replicated disk, it's going to have lower writes as well, right? So most people consider putting the temp DB on the local disk, but bearing in mind, if you put your data files on the cached ones as well, they're sharing the same throttle. So they're not going to be working independently in terms of that. I say a recent, but I'm so old that I think that April 2020 is recent, right? But in Azure, it might not be. A new technology introduced is bursting. So on new types of VMs, specifically the new ESV5 is probably the kind of golden child here. The VM and the disks can burst, and there's 2 types of bursting: credit disk and on-demand. Credit bursting is enabled by default on new stuff that you provision right now. But if you have an old thing, it might not be enabled, and might be a bit of configuration in order to enable it. And what credit bursting does is if you don't use your allowance of IOPS, it'll keep that, and it'll let you use that to go over what you're supposed to get. So if you've got a workload with peaks and troughs, it'll give you more during the peak. And it'll give you up to about an extra 170 megabytes per second per disk, capped at about a gigabyte per second per VM, right? Roughly, right? So, you know, it's quite a nice feature. And the second thing is on demand bursting, which I've just got a customer turn that on now, will let you, if your sort of disk only does a certain throughput, it'll let you use more, but pay for that extra bit, just to give you a little bit of extra boost. But the VM throttle is still going to be exactly the same. So the key lesson here is your VM has 2 throttling mechanisms that give you the maximum that it can do. So when you do your capacity planning, that's how you pick which VM you want to run your workload on, right? Now, when you go to the portal and you say, I want a VM, it'll give you this type of list here, right? One of the annoying things for me is it only gives you IOPS. It doesn't give you throughput. And because it's kind of half a marketing thing and it's built for app servers and not really SQL Server, they assume the I/O size is quite small when they quote the IOPS. From playing around, I know pretty much that they assume that you're doing a 16K I/O size. There's no way that kind of SQL Server is going to do a 16K I/O size, right? It's going to be 64 or something like that. So basically, if you need 4,000 IOPS from your SQL Server, that's probably the equivalent of about 16,000 IOPS as the Azure portal sees it, because the I/O size that they think is going to be 16K and not 64K, right? So you've got to be very careful of IOPS. You really need throughput. Now, it is actually published, but not on the portal, what the throughput is, right? You can go to, I put some links here. So the best VMs in the old days was the DSV2, and you can see here the amount of throughput that you get, right? So here we have a 768 for the uncached, 512 for the cached, right? And the ESV5 would be the kind of new one. So it is available on the portal. What I found is it's really annoying to just scroll through the kind of portal, and it doesn't tell you on the spec portal how much that will cost. So when you're doing the planning, I want to get the most bang for my buck, right? Because I've got a fixed amount of cash. Just buying the kind of biggest VM isn't going to suit me. I've got to balance cost, right? So what I did is I found there's an API that you can call to download all the VM specs. And there's another API that will download all the prices in your kind of region. And I put this up on GitHub as a sample project. There's a PowerShell file that will download all of the VM specs and all of the prices. Now, I did mine just for sort of Euro for the sort of Dublin data center. And when I did that, I made up this sort of Power BI chart that now lists every type of VM, and it gives additional information that's not available on the portal. For example, the megabytes per second throughput, cached, uncached, and total, how much is the VM, and then I added on SQL license costs, because it's so much per core if you're renting. So you can now say, I want to have a throughput between, say for example, I want an uncached throughput between 500 and a gigabyte per second. Say for example, I build a data warehouse. I want to run standard edition, and I want between 8 and 24 cores, and I want between 56 and 128 gig RAM. So once I've got my candidate VMs, I can now rank these to say, well, what gives me the most throughput, right? So the DS16 will give me 1,000 on my cached, 600 on my uncached, and the cost will be like this. Now, licenses is important, because if you're paying for Enterprise Edition, that's very expensive per core, right? So a common trick that we use, Microsoft introduced a SKU they called SQL Optimized VMs, and what they let you do is pay for a big VM that has all the throughput of a massive VM, and then only license a fraction of the cores. So you'll see here, see this second SKU is an E16-8. So what that means is only 8 of the cores are active, but you get all of the power of the 16 core in terms of throughput, RAM, and so forth. And this means that if you're running Enterprise Edition licensing, you'll see the cost of the one that's only running 8 cores is much, much lower. That's actually $7,000 a month, right? Because I'm not kind of licensing all the Enterprise Edition cores. So often we factor, if we go for standard edition, we can afford to buy a bigger VM and get better throughput sometimes, right? Up until we hit the limits of standard edition, which are about 128 gig of RAM and about 32 cores, right? So for a mid-level data warehouse, for example, 128 gig of RAM is going to easily do a terabyte or so of data warehouse, say, right? As long as you don't need enterprise features, you know, such as availability groups and stuff like that. Right, so that's something I did to help pick the VM. Now, once you've picked the VM, you've now got your components, right? So say, for example, you've got your sort of data and your log, and they've each got independent requirements. And imagine you had picked a DS at 14. I imagine nowadays you should probably pick the ES5, I'd hope, right? But if you did pick this one, the problem is, if you put all of your components on one of the caches, so say, for example, on the cached limit, well, that only does, I think it's 512 actually, but it only does, if you were to run them all, you can see that 600 plus 300 plus 156 is not going to fit on the throttle. So what's going to happen is your workload is going to be throttled at the VM level. So what you want to do is play around with moving the components. So the first thing that you're probably going to do is put the log on the uncached, because, you know, read caching isn't going to help a log because it's write only, right? So you might do that. You might, if it was a data warehouse, right, so the general best practice is put your kind of data on the read cache, right? But if you were running a data warehouse, right, and you had a buffer pool, we get better performance by putting our data file on the uncached. And if our log is in simple mode, right, so it's not a monster log file, we actually put the kind of data in the log on the uncached and move the temp DB to the local SSD to get all of the caching on the temp DB. Now, obviously, your mileage might vary depending on your workload. If you're doing an OLTP with a very heavy log file, you're probably going to want to put the sort of data on the cached one. But that's an example of how you try and use both of the limits if you can. Now, one of the big things is developing, check out for time, 12:22, that's good, is picking the right disk. Now, there's a bunch of different types of disks, but it's actually simpler than it looks, right? You've got your standard disks, your premium disks, and your ultra disk, right? And there's a couple of variations. I think they recently released standard SSD, which is the same performance as the old HDD, but its latency is a little bit better, right? The general recommendation is you always use premium disks for SQL Server. I chatted to a load of the other MVPs, and I was like, is anybody actually using ultra disks, right? And I couldn't find anyone around the globe who was actually using them, right? The concept of an ultra disk is great, though, in that you can get effectively provisioned IOPS and throughput by, on a small amount of disk space, specifying a high amount of throughput and just paying for that, right? In practice, most people have found out that if we take the 4 gigabytes per second that you can get out of an ultra disk, finding a VM that has that throughput capability is really hard, because most of unless you're running like 128 cores or something like that, you're not going to be able to feed an ultra disk at 4 gig, right? And by combining the premium disks, you can get pretty good performance. So for most SQL houses, the premium disk is kind of the only show in town, right? I did ask, here's a little sort of Twitter thing that I think Alan and Joey, who are two very well-regarded folks in kind of SQL config, I was like, anyone actually use the standard SSD? And they were like, nope, right? One thing for our customers, which I always encourage them to use the premium, especially on the production, is in Azure, there is an SLA where even with a single VM, without an availability group, they still give you a 99, is it 99 or 99 point? I think it's 99.9% SLA in terms of uptime, right? But there's some small print only if you're running premium disks. So if you put standard disks in your production workload, you won't get the SLA on the VM uptime. Now, is the SLA worth the money it's kind of written on? Because if it doesn't meet the SLA, all that happens is Microsoft refund a bit of your credit, which, you know, if you've had obviously downtime, getting a few $100 in a refund isn't going to help you. But for most of our customers, they want to have the SLA, so they go for the premium storage, right? Now, once you've decided on premium storage, there's a bunch of SKUs between P4 and P60 that determine the size of the disk and the throughput of the disk, well, and IOPS as well, but I mainly look at throughput, right? So what you can see, for example, is the P30, which is a really common disk, is a terabyte and gives you 5,000 IOPS at about 200 megabytes per second, right? So, you know, that's not bad. So what I did is I brought that into Excel. So here's an Excel spreadsheet, all the premium disks, all the price and throughput. I'm cheap, right? I don't want to know about how much size you have and how much throughput. I want to know, for the throughput, how much am I paying for every megabyte per second that I'm getting, right? Because this is going to tell me the value for money on the throughput. And what you'll see is, if you were the cheapest person in the world, every megabyte per second, the smallest disk, it only costs you 3 cents to get a megabyte per second, right? So if you wanted to get 100 megabytes per second by using the smallest disks, it would only cost you €3, right? Be ridiculously cheap. Now, obviously, the disks don't let you, the VMs don't let you put that many disks in them, so it's completely impractical. So there's a balancing act, right? If you only put the largest possible disks in, to get throughput, you'll get 900 megabytes per second, but if you want another 900, it's going to cost you an extra disk, right? So it's going to be quite expensive. And then I balance that with the cost per terabyte in terms of the capacity of the disk, right? And what you'll see is as you get larger, it's cheaper per terabyte, but it's more expensive per throughput unit. So if you're interested in throughput, you don't want to use big, large disks. You want lots of small disks and to combine them. And when you plot this on a chart, you'll see there's, if we look at the orange, which is the cost per throughput, there's an exponential line. I don't know who was in marketing on the P50. They missed the plot, right? Because it was supposed to be there. But the P50 is a lot more expensive than the P60 or the P40 per unit of throughput for some weird reason, right? But you can see it is kind of a line, right? Whereas the cost per terabyte is linear as opposed to exponential. And what this means is there's a sweet spot at the knee of the curve where the cost per throughput unit is still quite low and hasn't accelerated yet. And if you use that as your building block, we find that's the sweet spot for price per performance. That's the P10, the P15, the P20, right? That type of range, right? So what you've got to do is if your VM has a throttle of a gigabyte per second, you could give it 5 disks that have 200 megabytes per second. But you've got to be careful because you've got the cached and the uncached. So if you want to use them both, you need disks that are both cached and uncached, right? So you might need 2 pools of disks if you want to get the most out of it. So once you've selected how many disks you want, and we always try and get our disks to magically match the maximum throughput of the VM. So if the VM can do a gigabyte per second, as I was saying, we build disks to also do that. So we have what we call a balanced throughput, where all components can work at the same maximum throughput, right? What you don't want is a really big VM and a disk that has a quarter of the capacity throughput-wise, or your workload isn't going to be able to use all that you've paid for, right? So once you've got those disks, you have to combine them to get the throughput of all of the disks, right? And that's done in Windows storage spaces, right? So you basically go into Server Manager, you configure a storage pool to combine all of the disks, right? And then you create a virtual disk inside there. Now, the important thing of the virtual disk is that's like a bunch of disks that can be split up into volumes. There's 2 properties that you set that are absolutely critical. One of them is the number of columns. How many disks do you want to participate in performance? And for me, the answer is always exactly the same. All of them, right? But if you make a mistake there and you put in 8 disks but set the number of columns to 4, it's only using 4 of the disks for the performance. So if each disk can only do 100 megabytes per second, you'll only get 400 megabytes per second. But if you had a number of columns to 8, you would get 800 megabytes per second, right? So number of columns, we like to be as large as possible. Now, obviously, if you've got 16 disks, then you might use a smaller number. But generally, we use as high as we can go. The interleave size tells you the optimal block size, or I/O size, or stripe size, it's sometimes called in storage terms. And this is what is the size of a segment on the actual disk. And you want that to match the I/O size that SQL Server is doing. So generally, that should be 64K. But if you are doing a data warehouse and you do have a data volume with lots of table scans, you might up that to 128 or 256, right? And only if you've got the world's greatest DBA and the least fragmented data warehouse in the world would you put that to 512, right? So I would stick at 128 256 for most of our data warehouses on Enterprise Edition. If you're running Standard Edition, you always put that at 64K, because there's a bit in kind of Standard Edition where it won't do more than 64K I/O size on table scans, reader heads. Okay, and then you create your volumes. I think when you format it, you have this thing called an allocation unit size, like when you format a disk, right? You always set that to kind of 64K. Most people confuse that with the interleave size. They're completely different, right? One is just how is it formatted. The other is how large is each blob that I get off the disk, right? They're completely different. But if you're unsure, most people set them both to 64K. Now, how do I do this configuration in storage spaces? 3 ways of doing it, right? One, you can, the portal, so when you configure a SQL VM now, and this was only upgraded a couple of months ago, it used to be quite rudimentary. So last time I did this talk about a year ago, I had some advice of never use the sort of portal because it wasn't really flexible enough. But now they've upgraded it, it has a lot more options, right? And it's actually pretty good. So what you see here is on the portal, if I just zoom in there, you can specify now the number of disks, and the wizard will automatically create that storage space. It'll put in the number of columns for you. It'll create your virtual disk, and it'll create a volume, which it will call the F drive, which it will put all your sort of data on there. And for your log, you can choose on a combo box to share the log and the kind of data drive, or create a separate pool for the log, and the same for TempDB. So this is pretty good. There's only one thing it's missing. It doesn't allow you to specify the allocation, the stripe size. It always sets it to 64K, which is interesting because the previous version of this did let you pick that. So I've been meaning to ask someone at Microsoft, why did they lose that kind of feature of being able to specify? So what that means is if you're running an LTP or you're running Standard Edition, the wizard can do everything that you need. But if you've got a data warehouse where you want a larger I/O size, you're going to have to manually configure it, right? Now, I'll show you, just check the time. Yeah, 12:33, I've got time for a demo, hopefully. I'll show you how to manually configure it, right? 2 ways of manually configuring it. One is you can just point and click, go your way in kind of Windows. If you go into Windows storage spaces, you can, after you've added all the disks via the Azure portal, you can go into storage spaces, create a storage pool, create a virtual disk, and then add volumes to that, right? I prefer to do it in PowerShell. There's a single line command which will add disks to VM. There's a new storage pool command, a new virtual disk command, and there's a format volume command, all available in PowerShell, right? The reason I like the PowerShell is for some of our customers, when it comes to disaster recovery, they're quite cheap, right? So they're like, we don't want to have a VM running all of the time just in case of a disaster, because they could be running a data warehouse with 10 terabytes of disk space. So having to pay for that much storage in the DR is very expensive, right? So what they do is in their DR site, they have no storage. They pay absolutely nothing. And we configure the storage on, and we configure the basic storage on the fly. As a DR event happens, we create all the storage, create all the virtual disks, create all the volumes, and then we restore the SQL backup from the sort of blob store or wherever all the SQL backups are, right? So in that way, we can get a cheap form of DR by using kind of PowerShell. And actually, I just literally did a DR test for customer. So I've actually got the production DR code here, right? So here, I've got a VM. And it's literally a stock VM that just has a C and a D drive, right? And what I can do is I can run this code. You'll see there's a PowerShell loop for I to a number of disks, add a disk, and then update the VM to see the new disk. So when I do this, I run this script, and what I get now is a load of disks added. And if I went to the portal, go to the portal, what a time for internet to go down, man. I see I've now got, no, there's my refresh. Yeah, hopefully, hold on. Oh, so I already had some of the disks added, whoops. Oh, sorry. Classic presenter mistake. He ran his demo a bit before and didn't clean it down kind of smoothly. Noob. Right, so I'm just going to delete that last disk and try that again. So now I'm going to try and create those 6 disks again. So 1, and if I flip over to the portal, let's just see if we can create that first disk there. So this is going to go over to the portal. It's going to add a disk, attach it to the VM, add another disk, attach to the VM. And you see that's part of the script. I can specify if I want it cached or uncached. Now, I've said uncached, but it could have been cached as well. So you can see it started to add the disks. And let's just flip over to the portal. We should start to see those disks coming into the portal now, right? So let's go back. Virtual machines. Disks. Hey, I've now got 6 half a terabyte disks. Now, notice I'm using the P20s, the half terabyte disks, because I want to get that 150 megabytes per second per disk, times it by 6, 150 times 6 gives me roughly 900 or so, which just so happens to be the limit of the VM, right? Whereas if I'd have used the terabyte disk, I wouldn't have hit the limit of the VM, right? So I'm using the smaller disk to get to my max kind of throughput. Now, once I've done that, I can, in here, run this script here, I can check disks are there, and then I can create a storage pool. I can create logical drives on those pools. So I'm going to create an F drive for my data volume, an L drive for my log. I've got an S drive for scratch for any backups or junk that people are putting on. So let's just run that script. And what you see now is that's now creating the storage pool and doing that. So we can go from an empty VM to all the storage fully there in 30 seconds or so, all ready to restore the backup. So I guess you think about this as a disaster recovery as code or sort of infrastructure as code, right? So, but we would also use this for for provisioning a new VM as such. So here I've now got all my drive letters. Going to my F, I've now got a data volume and so forth. And I could restore my SQL backup now, right? So that's effectively, what we do is we keep these scripts. So if we get another customer who wants another data warehouse, we just adjust all the scripts to say, well, they've got these disks, but there's more disks of a bigger size, of a smaller size, and so forth, right? Now, once you've got your disks and you've configured them, the most important thing to do is to benchmark it, because you probably made a mistake, right? Or you picked the wrong SKU, or even worse, you've got someone else to configure it for you, and you don't know if they've configured it. So the classic example is we go to the customer's infrastructure team and we say, can we have 6 uncached disks and 5 cached ones? And they just make them all cached. And we don't have any access to the portal. But by using benchmarking, we can say, no, 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 I'm pretty sure that you haven't given us what can we ask for, because we're not seeing the throughput, right? So this is where benchmarking comes in, right? Now, there's a number of tools we use for benchmarking, right? There's a very old tool that a lot of people use called disk speed. It's a command line tool. Disk speed, what you do is you run it with a set of parameters. And one of the parameters is the number of outstanding I/O, which is how hard am I pushing it, right? How many I/Os am I asking for? And what you do is you start off low, like only 1 outstanding I/O, and then you monitor the latency and the throughput of that, and then you increase the outstanding I/O, and you gradually do that until you stress it to max it out, right? And we draw a chart exactly like this. The blue chart is the throughput of the VM, okay? And the red chart is the latency. And most of the time, you'll reach, especially in Azure, it will look like this. We have linear scalability. As we increase our outstanding I/O, so I'm making calls, suddenly at 150, because I think I must have been on a single P20 disk, a flat line. Doesn't matter how many outstanding I/O push, I'm not getting more than 150 megabytes per second, and my latency, which is the red line, just increases exponentially. I've hit the limit, so I now know I'm getting throttled at 150 megabytes per second. So I could go back to my infrastructure people and said, hey, I asked for a P30 at 200 megabytes per second, but I'm only getting 150. Are you sure that you gave me a P30? Or if I know that the cached has a limit of 500 and the uncached is 756, if I get 500, I'm like, I'm not getting what I paid for, right? And the ultimate goal is to hit the VM max. So if the VM can get 500 on cached and 800 on uncached, if you get both at once, happy days. You are maximizing your investment, right? So by far my favorite tool nowadays is Crystal Disk Mark, because in the old days I'd have to spend ages writing disk speed scripts and interpret them. Crystal Disk Mark, you just download and hit go, and the top left figure gives you the max sequential throughput, and that will tell you what you can get out of the combination of the disks and the VM to see if you've configured it incorrectly, right? So say, for example, you bought a VM expecting 800, but you've only put a disk that can do 200. You can tell by this roughly where the sort of problem is, right? Now, a word of warning, the new burst technology messes with benchmarking, because the burst allows you to go up to an extra couple of hundred megabytes more than you're capable of. So what we do is when we're benchmarking it, we turn off the burst functionality at the sort of disk level. There is a PowerShell command, or we benchmark on the uncached and then assume that we know what the cached one will be after it's set back to cached, right? So you have to be careful, because sometimes the cached disk can give you misleading results because of the bursting effect, okay? Oh yeah, I just left this in because it was quite interesting. The right-hand side is how I configured those. That's 4 disks with a VM that has a maximum of 768, and you can see I actually hit 786, so like it was pretty close. What is fascinating is you see the bottom left, storage optimization. In the old version of the portal, there was that combo box where it lets you pick from a sort of data warehouse in our LDP, and a few of you probably wondered, what does that actually do? That's what sets the stripe size to 64 or 256 in the virtual disk. And that's what's kind of missing from the new portal. So I'm like, where did it go? Anyway. Do not try this at home, right? I tried it for a laugh, and I was amazed with the results, but I haven't put it into production yet, right? Abusing the rules, right? Microsoft gives you 2 limits, cached and uncached, right? And unfortunately, there's a lot of complexity in what do I put on cached and what do I put on uncached, right? And this harps me back to my old days, so 20 years ago, where a SAM provider would give us multiple heads, and they'd say, well, you have to attach 1 disk to that head and 1 disk to that head, and you need to be a rocket scientist to really understand the workload. And the problem is, whatever you guess on paper is going to be wrong by the time it comes into production, because things change, right? So the other thing is, I'm not going to do any thinking. I'm going to create half of my disks cached, half of them uncached, and create a single virtual disk of a Frankenstein of completely random cached and uncached, right? Every professional I've told in the world about this has been like, are you nuts? You never do that, right? But I was like, well, let's just do it and see what happens, man. So I did. And when I did that, on a single run, I managed to get both of the cached and uncached pools combined for my kind of data volume. But the problem is the I/O pattern would be like it'd be reading and it'd be cached, not cached, on the block level. So it was quite funny, and it's what I call a Frankenstein. But actually, I wanted to do a bit more research to see if it'd be a mainstream, because it comes back to the old Oracle term, stripe and mirror everything. It's, do you put everything in a single pool that's really big, or do you try and be a rocket science and individually separate components? So it's that isolation versus consolidation argument, right? So you can actually combine cached and uncached actually disks, but I wouldn't recommend it for a production environment because everyone I talk to says, don't do that, right? So lessons learned. Yeah, kind of worry more about throughput if you can, because the IOPS that are quoted on the VM sites aren't aimed at SQL Server workloads. They're aimed at app server workloads, so they're not what you're going to get when you're running SQL Server. If you really want to convert them to what you're going to get, divide them by 4, because Microsoft assumes it's a 16K I/O and you're going to be doing a 64K I/O size, right? Conversely, if you, there's a number that you can divide the IOPS to get the megabytes per second as well. So if you get your IOPS that they give you, multiply by 16 and then divide by 1024, you'll actually get the number of throughput that you'll actually get at the SQL Server level. So you can use their metrics, but I prefer to just get their throughput metrics instead of the IOPS and just kind of use that. I find that more reliable, right? So that's kind of the lesson learned. But the key thing is to make sure you benchmark, because you can make a mistake. You can have a team who's configuring things for you who makes a mistake or didn't quite understand the requirements. But if you benchmark, you can get away that. Now, some good news is I delivered this talk about an old version of this talk, because obviously Burst has come in since then. And I had a wish list of things that I wasn't happy with, right? And I was like, the VM don't fit my workload, because for SQL Server, we want a low number of cores, because they're really expensive, and we want lots of I/O, right? And I couldn't find any VMs that had that sort of pattern. Microsoft released the constrained VCU, or the SQL Optimize. I wanted a provisioned IOPS. I was like, what if I want to pay to just give me lots of throughput on a single disk? And they did that. Yeah, I wanted storage that could be geo-replicated. They do that in managed instance, right? I wanted smoother configuration. The new wizard kind of does that, right? So now, just before the end, I don't think I quite got it across my talk, actually, but I did a blog about this. I should mention that when you're picking the VMs, if you're on the DS series, the new E5 stacks up very well against it, right? I wasn't too sure at first. It gives you a little bit more RAM, gives you a lot more temp storage. So on an 8-core, it went from 100 gig on your temp storage to 300. But the key thing is it gives you the new burst capability and a higher cache throughput as well, right? And on my customer workloads for kind of data warehousing, it was 33% faster. So I'd highly recommend looking at that SKU. Right, that's me out of time. Please do fill the feedback out. There is a barcode there. There's a link there. It's 7,000 on the feedback form. If you've got an old link, just change that to 7,000. Let me know if the session was useful.